Every summer, HVAC contractors receive the same phone calls. The building is hot. The air conditioner is running but not cooling. The humidity feels unbearable. The utility bills suddenly doubled. And in many cases, the equipment itself is not actually broken. The real problem is that the system is suffering from one of a handful of common issues that appear every cooling season. In this video, we're going to look at 6 of the most common HVAC problems that occur during summer, explain why they happen, show what the symptoms look like, and discuss how they are typically corrected. If you understand these 6 problems, you'll be able to diagnose a large percentage of the comfort complaints that occur in both commercial and residential buildings. Let's start with one of the most common and most misunderstood problems. Problem number 1. Frozen evaporator coils. A customer calls and says the building is warm. You arrive and discover the evaporator coil inside the air handler is covered in ice. Many people assume this means the system is working too hard because it's hot outside. The truth is usually the opposite. An evaporator coil freezes because it is not receiving enough heat. The refrigerant inside the coil is designed to absorb heat from the air passing across it. When airflow becomes restricted, less heat reaches the coil. The refrigerant temperature drops below freezing. Moisture in the air freezes on the coil surface. As ice builds, airflow becomes even worse. The problem feeds on itself until the coil becomes completely blocked with ice. The most common causes are dirty air filters, plugged evaporator coils, failed blower motors, slipping fan belts, collapsed ductwork, or closed dampers. Low refrigerant charge can also cause coil temperatures to fall below freezing. The solution begins with restoring proper airflow. Check filters, inspect coils, verify fan operation, measure static pressure. Only after airflow is confirmed should refrigerant levels be evaluated. Many systems receive unnecessary refrigerant because the actual problem was airflow all along. Now let's move outside. The condenser coil is responsible for rejecting heat absorbed from the building. Think of it as the radiator of the air conditioning system. When dirt, dust, grease, or debris accumulate on the condenser coil, the system struggles to release heat. Head pressure increases, compressor amperage rises, cooling capacity drops, energy consumption increases. The equipment may still run, but it becomes increasingly inefficient. Imagine trying to breathe through a heavy blanket. That's essentially what the condenser fan is trying to do when the coil becomes clogged. A dirty condenser coil can reduce efficiency dramatically and may even shorten compressor life. The solution is straightforward. Inspect condenser coils regularly. Follow manufacturer cleaning recommendations. Use proper cleaning chemicals when appropriate. Avoid high-pressure washing that can damage coil fins. A relatively simple maintenance procedure can prevent expensive repairs and significantly reduce energy consumption. Many cooling complaints have nothing to do with refrigeration. The real issue is airflow. The HVAC system may be producing cold air, but that air is not reaching the occupied space in sufficient quantities. Airflow problems can result from undersized ductwork, dirty filters, blocked coils, closed dampers, collapsed flexible duct, leaky ducts, improperly adjusted VAV boxes, fan issues, or excessive static pressure. The symptoms are often easy to recognize. Certain rooms are always hot. Occupants complain about uneven temperatures. The equipment seems to run continuously. Supply air temperatures look normal, but comfort remains poor. Think of airflow as the delivery truck for cooling. The refrigeration system creates cooling. The duct system delivers it. If the delivery truck never reaches the destination, the cooling never reaches the occupants. The solution is to measure airflow instead of guessing. Verify fan performance. Measure static pressure. Inspect dampers. Review duct sizing and ductwork for leaks. Confirm terminal units are operating correctly. Airflow measurements often reveal problems that temperature measurements alone cannot identify. Problem number 4. High indoor humidity. This problem becomes especially noticeable during summer. The thermostat may indicate the correct temperature, yet occupants still feel uncomfortable. The air feels sticky. Windows may fog. Condensation may appear on diffusers or ductwork. The problem is humidity. Many people do not realize that air conditioning systems perform two jobs simultaneously. They remove sensible heat, which lowers temperature. They also remove latent heat, which removes moisture from the air. When moisture removal is inadequate, comfort suffers. One common cause is oversized equipment. An oversized unit cools the building quickly and shuts off before enough moisture can be removed. This is known as short cycling. Other causes include excessive outdoor air, economizer problems, building pressure issues, control problems, or inadequate reheat strategies. The solution depends on identifying the source. Verify equipment sizing. Evaluate ventilation rates. Check control sequences. Inspect economizers. Review building pressure relationships. In many climates, controlling humidity is just as important as controlling temperature. Problem number 5, short cycling. A healthy HVAC system should operate in reasonably long cooling cycles. When a system starts and stops repeatedly throughout the day, efficiency suffers and equipment wear increases. This condition is known as short cycling. The compressor may start, run briefly, shut down, and restart again only a few minutes later. Each start places stress on electrical and mechanical components. Common causes include oversized equipment, faulty thermostats, refrigerant issues, control problems, dirty coils, restricted airflow, or safety devices that repeatedly trip and reset. Short cycling creates several secondary problems. Humidity removal decreases. Energy consumption increases. Comfort becomes inconsistent. Equipment life expectancy is reduced. The solution is not simply replacing parts. The underlying cause must be identified. A proper diagnostic process often reveals that short cycling is actually the symptom of another issue occurring elsewhere within the system. Problem number 6, excessive energy consumption. This is often the complaint that gets management's attention. The building appears comfortable, but energy costs suddenly increase. In many cases, the HVAC system is consuming far more electricity than necessary. The challenge is that energy waste is usually not caused by a single issue. Instead, it is often the combined effect of multiple deficiencies. Dirty coils, restricted airflow, failed economizers, improper schedules, faulty sensors, simultaneous heating and cooling. Improper VFD operation, control sequences that are no longer functioning correctly. The HVAC system continues to operate, but efficiency gradually deteriorates. Many buildings waste energy for months or even years before anyone investigates. The solution begins with measurement. Trend data. Review operating schedules. Inspect equipment conditions. Verify control sequences. Analyze utility data. Buildings that regularly monitor performance often discover substantial opportunities for energy savings without replacing major equipment. Final thoughts. Most summer HVAC failures do not begin as catastrophic breakdowns. They begin as small issues: a dirty filter, a plugged coil, an airflow restriction, a control problem, a failed sensor. When these issues go unnoticed, performance declines. Comfort suffers. Energy costs rise. Equipment reliability decreases. The good news is many of these problems can be identified and corrected before major failures occur. Understanding the relationship between airflow, refrigeration, heat transfer, humidity control, and system operation is the key to diagnosing HVAC problems correctly. The next time someone says, "The air conditioner isn't working," remember that the equipment may not actually be broken. The real problem may be hidden somewhere else in the system. And finding that root cause is what separates troubleshooting from guessing. If you found this video helpful, be sure to check out our HVAC and plumbing estimating spreadsheets to streamline your construction bidding process. Check out our HVAC, electrical, and plumbing construction forms to help you run your business, and explore our online courses for in-depth training.